Hello friends, this is Durga from IT Varsity. So as you guys know, this is backup for my live audience. So those who are on YouTube, if you have any questions, if we cannot answer them in timely manner, bear with us. So that being said, originally the training session was planned only for 20 hours, but and I already have extended for 2 more hours. But few of the topics are not covered because of spending too much time on Scala collections, and also uh, uh, yeah, that is the primary reason we are at least 3 4 classes behind by the time Scala is done, which have actually impacted the overall schedule. Um, I thought of showing the online material, and if you guys stuck somewhere, I thought of supporting you, but some guys are not comfortable with that. So I have decided to conduct a few more sessions and cover all the topics which I have told that I'll be covering as part of the training originally. Okay, so that being said, we will primarily focus on the components that are missing, that are missed out as promised. So I'm going to Apache Spark using Scala course, and one of the thing that is missed is the accumulators and broadcast variables. And also, I got feedback that the training was too basic because of the word count example. The reason why I have explained using word count is to explain the development lifecycle, execution lifecycle, and all those things. And they are not basic; they are quite a bit advanced stuff which I have covered about how to take care of how to take care of sorry yeah how to take care of problem statement depending upon the demand based upon the data, how to configure the memory related parameters, understanding the capacity of the cluster, and all those things. So the reason why I have taken word count example is because I have 30 GB worth of data, and it will make some sense by seeing the volume when I change these memory settings to explain it. Apart from that word count example, I try to be as realistic as possible. From day one, I have been explaining using retail DB dataset. Even with Scala collections also, I have gone quite a bit of depth, and I have explained how to query from the databases, how to load files, and use core Scala collections, and all those things. So yeah, except for that example which I have picked, everything else is a bit advanced, and you don't see online budget searching for that material. That being said, also I got the feedback saying that my website is slow. I have been asking this quite for some time. Website is not slow. I am paying quite a bit of money to AWS for this. It is running on a I think larger some instance. For the traffic I'm getting, I have configured using a much bigger cluster. So that's why I have messaged on WhatsApp also. If you feel that website is slow, let me know so that I can troubleshoot. But from our side, I think it is as fast as it can be. If you are using your laptops behind proxies, or if the internet is slow on your side, that could be the issue. But that I can only narrow down if others can respond whether website is slow or fast for you. That way I can actually troubleshoot whether it is the problem on our side or problem on your side. Okay, so please respond if a website is slow, so that I can take the necessary action. Okay, so that being said, let us focus on the accumulators and broadcast variables. For that, I will take a bit realistic example. You can see as part of the material, even though there are no videos, there is an additional topic. I have covered develop word count application referring to this material, and there is additional topic which says more Spark concepts and core APIs. And as part of that, uh, uh, we have the examples for map partitions, accumulators, broadcast variables, and all those things. Um, I have already covered how to determine the number of tasks at each stage, how the tasks are determined at the map level when the data is being read from the files, and also how to determine the number of reducers later and how to configure it. There is an untouched parameter for each and every transformation, such as join, reduce by key, aggregate by key, etc. And you have to use that, and it will take care of customizing the number of reducers for your processing. So these three topics are covered as part of this more Spark concepts and core APIs. On top of it, if you want to play with the size of, if you want to increase or decrease the number of partitions in the RDD while reading the data using sc.text file, there are coalesce and repartition APIs, and I have covered that also. So now I will not be covering map partitions, but I will be covering accumulators and broadcast variables. Map partitions is not very important, and if you want, you can go through the material, and it will be clear to you. But one of the thing I have mentioned as part of the curriculum is accumulators and broadcast variables. So I will start with that. Before getting into the details, let us define a problem statement. The problem statement is to get revenue per product for a given month. Okay, so out of this problem statement, revenue per product for a given month, revenue is available in order items. Okay, and date is available in orders, and product details are available in products table. Let us assume that we have only orders and order items in the database or in Hadoop, in HDFS. There is no products table. Okay, even though I have already copied products table also, let us assume that there is no products table. So we will try to load the products data set from local file system as part of our program, and then join with the orders and order items which is already available in HDFS. So we can actually use Scala.io.source, which we have seen, to read any local file, and then use parallelize to create a distributed collection or RDD to join with the rest of the files. So these are the problems which you will typically get. You might have to load some files from the local file system on top of whatever data you have in HDFS or some other file system where the data is already distributed. So in those cases, the way you should start, as Balu have asked yesterday also, what should we use in this case? Should we use Spark SQL in high context, or Spark SQL in native context, or data frame operations, or pure RDD stuff? What should we use in this case? So if orders and order items have Hive tables already, in this case, I mentioned that only orders and order items are in Hadoop, and products is not in Hadoop. When you say data is in Hadoop, it can be part of Hive table also. So let's say orders and order items are in Hive. In that case, what we can do, we can run a query joining orders and order items. Because products is not in Hive, we cannot actually join that with the Hive tables. It is not possible. Hence, we only have to join orders and order items, and from there we can get date and order item subtotal as well as product ID for each and every record in order items. Okay. Once you get that information, product ID, order date, and order item subtotal. Once you get that information, if you have Hive table, you can directly run Hive query. If you don't have Hive table, as the data is already structured, what you can do, you can actually create case class for orders, order items, and also products is actually in local file system, right? So you can actually create load products also into RDD by running Scala.io.source, and then read lines will create a collection, and we can use parallelize. If you recollect, it will create an RDD, So you can create RDD of product also, which is in local file system. On similarly on orders and order items also you can create RDD for those data set. And once you create RDD, you can convert it into data frame. If you convert all these three into data frame, you can run SQL in either Spark native context, or you can perform data frame operations. That you can decide whichever way you want to address the problem. If you are comfortable with data frame operations, you can go ahead with data frame operations. If you are comfortable with Spark SQL in native context, you can go with Spark SQL in native context. Okay, but when you are using Hive, it is not possible to join the products table with them. You have to get orders and order items joined together. And once you get orders and order items joined, the result will be a data frame. You can also create a structure for products. It will be a data frame. And then you can register them as temp tables, and you can join them again. That is another way to use both Hive as well as loading data from local file system. If you don't have, as the data is structured, these are the options you have. On top of all these things, you can also use Core Spark APIs to perform whatever transformations and actions you want to perform directly, and you can process the data. Only thing is, orders and order items have to be read using sc.text file or using APIs that are part of SQL context if the files are of different file format. And products, you have to read from local file system into RDD, and then you can perform transformations using core APIs. So we will take that part. We'll only use core transformations and actions. But when it comes to your project, depending upon the timelines and your convenience with programming, you can use any of the approach. You don't see much of a difference whether you use hybrid approach with Hive to query orders and order items, and then use core transformations and actions to join a product. That is a hybrid approach. Or you can use uniform approach using Spark SQL after converting data frame of each and every data set. Okay, it's up to you. You can go ahead and implement the way you want. Okay, so now I will be using IntelliJ IDE. First, we will try to develop with the knowledge we have around the core transformations and actions. Then we will see the value of broadcast variables. Okay, accumulators also I will cover a bit about accumulators also as part of that process. So I might not go in the exact same order the way material is created here because of the time constraint. First, I will create the program to generate revenue per product for a given month using core APIs, and then we will actually either first cover broadcast variables and then accumulators, or we will cover accumulators and then broadcast variables. Okay. So most of this stuff is already ready. We have the application.properties, dev.execution mode pointing to local, prod.execution mode pointing to YARN client. So we'll be using typesafe config to load these things, and then depending upon the environment we are running, it will run accordingly. Okay. So, okay. So here I'll be creating a new Scala class. What is the problem statement? Revenue per product. Revenue per product per month. Okay, let me change it to object. Let me use the same name as I have in the material. Yeah, revenue per product per month. Okay, so per month, So the problem statement is per month, not per month. So for a given month, which will be passed as argument, I want to compute the revenue per product. So that is the requirement. Okay. So first I have to define the main function. Okay. Then the first parameter will be whether I want to run it in dev mode or production mode. So you can see here. The second parameter will be input path. That will be the base path of our dataset in HDFS or local file system. The second parameter is output path where I want to store the data. And then we have additional parameter to just read the products file, because I want to get orders and order returns from HDFS and products from local file system. Even when we run on the cluster, we will be doing the same thing. So the fourth parameter is to give that local path from where I want to read the products data. And fifth parameter is our argument is the month in which I want to get the order revenue by product, revenue per product for that given month. So the program takes 5 arguments. Okay, so I will be copying most of the stuff here because this is all covered. You can see I'm also handling the whether the path exists or not for the input and output path. If you want to do similar validations for our local path, you cannot use the HDFS. Yeah. Even for that, you can use HDFS APIs themselves. Okay, you need to understand how to validate the local path, and based on that, you have to make the necessary additions to your logic, where you can validate the local file system also. Okay, so I will be copying this one directly. I hope you guys are clear on this. I need to do the import, so let me import these things. If you have any questions here up to this point, let me know. Otherwise, we will move on. Okay, and this one also you guys already know. I'm actually filtering, reading orders. Okay, once orders is read, what we are supposed to do? We want to first filter for a month, because that's our problem statement is get revenue per product for a month. Okay, so whenever filtering is there, the filtering should happen first more than anything else. Okay, that's why first I want to filter uh, for the given month. Okay, and here I'm creating orders filtered equal to, we can say, orders dot map, sorry, filter. Ideally, you should use Spark Shell or Spark Shell to validate these things, and then add the code snippets to the program. That way, you will be testing these things immediately. Otherwise, if you want to test using your IDE, every time you run this, it will take at least a minute or two. Okay, so here, so there is a question here. So we are trying to cover accumulators and broadcast variables, Ashish. Okay, first I have to say uh, sc.text file, and orders. and here I have to uh, check for the uh, month will be passing. So order date is the second one. So this one will give the month details, so date details, and from there we just have to check for the month. And the way we will be passing it as a string format, which is YYY-MM. And as our data is in the same format like YYY-MM-DD, blah blah blah, we can use this contains for applying the substring function. For example, if I launch val in path equal to, I'm running on the cluster, so I'm using the path which is available on the cluster, orders. Okay, and then I can say sc, yeah. So I can say sc.text file orders.filter. Okay, and in this we are actually testing. Before that, let me just say orders.first to get the record. Sorry, in path. In this case, I can. Okay, let me do this. Let me just use in path 2 here, and then sorry, it should be orders. As per the program, it is orders. So let me change the path name to orders, and then let me run this. Okay. Sorry, I know what I am. Here it is in path, and then orders equal to in path plus orders. This is the orders path string. I have to put val before it. Okay, so I have created two variables in path and orders. Now using orders as path, I am trying to read the data, and using first I got the first record, and this is our date, which is in YYYY-MM format. So if you take a string of that format, okay, you can actually, if you just want to compare substring of it, you can say 2013-07, or I think s dot contains 2013-07. If it is the case, if the substring works, it returns true. Otherwise, it returns false. Okay, so we are applying the same logic as part of the filter. Okay, so here I am saying one dot contains, and I have already created a variable called month for the fourth parameter. Hence, I can use that directly. What is the problem here? Okay, it is like this. Okay, so this will filter. Okay, I have to have one more curly brace to close the main function. Okay, so this will filter the orders for the given month. We can validate if you want, but I don't want to get into that details at this time. And then I have read order items from here. Again, I hope there is no question here. Yeah. And then on the filtered data with on the filtered orders, I'm trying to join uh, with order items. So this entire logic actually compute the revenue for that month, for the month which we have passed. Okay, so let me see if there is some issue here. sc.text file dot don't know why it is not working. Just give me a moment. Probably there could be special characters that could be calling the issue. Let me see. Y equal to order item dot split. Then I just want to copy this thing. Okay, let me see where the problem is. Sorry for this. I think it got some special character somewhere. What happened? Okay, I know what is the problem. Here, after filter, I have to apply the map function also. Okay, then I have to get order ID. Let me copy paste here to save the time. Yeah, this is the missing part. Okay, and I think that is the problem. Let me copy paste the code. Okay, so the reason why I'm mapping with into a tuple with one for each and every order is, apart from filtering, I don't need any other information from orders. So it is just a placeholder to create a tuple. We will ignore that later. Okay, and using this information, we joined with order items. From order items, we need order ID to join initially with orders, and then as part of the value, we are trying to get order product ID, which is the third parameter, so third attribute in order items, and order item subtotal. We need product ID and order item subtotal. That's why we got those things. Once we join the data set, this will actually one minute, let me, yeah, this will actually get only these two things, which is product ID and the order item subtotal, like dot underscore two dot underscore one. Let me show you that so that it is clear to you. So first, let me run this portion up to join. Okay. And then take off 10 for each println. Okay, first I have to read the order items. I think it is in path. Okay, small p. Okay, now I can copy this thing from here. So I hope you are clear up to the join. Once you join, what happened? Yeah. Okay, let me do this. Let me run this code snippet. Sorry, history. Okay, so here let us say I want to get it for 2014 January. Dot. So we got the orders filtered. Now I'm joining the data. Okay, now it is working. So once you join, what is happening? We join order items to orders. So this is the order ID which is common between the two, and this is the join results. The first one is from order items, which is a tuple, and the second one is just one, which is just a placeholder for us so that we can join with order items. So we are trying to extract this one. Okay, if you have a tuple like this, val t equal to like this. If you want to read this one, we have to use t dot underscore 2 dot underscore 1. If you just say t dot underscore 1, it will give us this one. If we just say t dot underscore 2, it will give this one, which is a tuple again. And we need this one. Okay, so t dot underscore 2 dot underscore 1 will give us the product ID and order item subtotal. So this is the product ID, this is the order item subtotal. And then once we get that, we just need the count by product, right? So we can group by product, product ID, and then we can get the revenue for that product. Okay, that's why we are using reduce by key at the bottom. Once you use reduce by key, for each product you get the results. But it gives us only product ID. Now we need to get the other product details such as product name, description, etc. For that purpose, we have to join with products data set. As I mentioned to you, products is we need to read products from the local file system, right? So for that reason, I have created another variable called local path, where I am assigning the fourth argument, which is the products path. And then I am using the scala.io.source to read from the local file, and then I convert into collection using getlines, and then I have used parallelize to create RDD out of it, and I actually joined with our revenue by product ID by separating the product ID and the product name. into the tuple so that we can join the revenue by product ID with products on product ID. And finally, we try to get the product name and the revenue associated with the product name. And we are trying to save the results to output path. Okay. As part of this map, if I do not use this map and when we use save as text file, it will save in the tuple format, something like this: product name and then revenue, which let's say 1,000. It will save like this. If I want to save it in a proper format, I can apply map function on top of those joined results and extract whatever information I need, which is the join value after joining the results. And then I'm using this product iterator dot make string on the tuple to make them tab delimited, and then I'm saving using save as text file. Okay, so let me read this. Let me run this and validate, and then we will also run on the cluster. Okay, so the local path is the facts of tree. It is under slash data slash retail underscore db slash. I think that's it. We need to pass. Yes, and then I have added the additional path of products and the file name with. Okay, import scala.io.source. Okay, now we can actually run up to this. I'm running only till the join. I hope it is clear. I'm just creating the tuple to get the product ID and product name. Okay, we can actually save first to get the first record. Okay, earlier I haven't assigned it to the variable. So let me run this here. And now let me run this. Record first. We'll give one record. You can see it is of type tuple. The first one is the join key, which is product ID, and the second one is a tuple. This is from products dataset, which we just loaded and joined. This is the revenue. So if we read it as a tuple, to read that as tuple, we just have to say, let me create a tuple of this. Actually, I can say t equal to the previous results dot first, and it will assign it to it. Okay. Now I can say t dot underscore 2 to get this nested tuple. To convert into a string, there is a function called product iterator. So you can use product iterator, and then you can apply an additional function called mk string. Okay, so where is that mk string? Mk string, and you can tell using which string you want to concatenate. And now, okay, so here I read everything. If I just need to get the tuple, I just have to say t dot underscore 2. This product iterator is available in almost all the collections as well as tuples. Okay, so here t dot underscore 2 will give the nested tuple, and if I want to apply mk string, I can perform product iterator on that tuple and then mk string, and then it will you can give whatever delimiter you want. Let's say if I want to give column, I can give column here, and you can see the delimiter is column. Okay, and then I'm saving it as text file. So in case if you are asked to save it in a particular format, you can take this approach. Also, if you are not comfortable with this, you can say t dot underscore 2 dot underscore 1 plus tab plus t dot underscore 2 dot underscore 2. That will also work. Okay, but you should be familiar with this approach. This is more functional approach. Okay, so now we have completed the program. As I have been okay, I have to say I have to add this additional code snippet. I haven't completed it as part of the file. Okay, so I'm adding this part also, and also I have to add. Let me do this. Let me just copy everything as I have already explained. That way I don't need to worry. Okay, now you have created the program completely, and what you can do, you can copy this path. You should be able to validate using IDE also. It just takes 5 parameters, and just to recollect, you go to run, click on edit configurations, make sure this program is there. If it is not there, you have to add it by saying this, and choose the main class which you want to which you want to create. So this is our main class, and I want to name this also with the same name. And then you have to add all those 5 arguments. So in this case, as I'm running locally, both input path as well as product path will look similar, but when we actually run on the cluster, it will be a bit different. It takes 5 parameters, so you have to add all those 5 parameters. You have to choose the class path of the module, and then you can say OK, and then you can run it from here. Once you run it from here, I'm not running right now. I'm just showing how to run on the cluster. You can copy the path, go to the path, and then run SBT console and build the jar file, and then take the jar file onto the cluster and run on the cluster. I will run on the cluster and show how the execution plan, and then I will add broadcast variables to it. Okay, which one is this? It is let me delete this. Oh, sorry, it's not SBT console. It is SBT package. Okay, now I can actually copy this to the cluster. And then you log into the cluster. So there is a Spark submit command also here. You can directly run this. Okay. So you can go to this port number 54123. Okay, GW01. Okay, it is already ran. So I'm going to resource manager. Okay, click on history, click on the job. So there are 5 stages to it as part of the program. You can also see the DAG directly here. As part of the first stage, it actually read the data from products, applied the parallel, and did the necessary transformation. As part of the second stage, it has read the orders data. As part of the third stage, it has read the order items data. As part of the fourth stage, it has joined the orders and order items. As part of the fifth stage, it first did the aggregation on product ID, and based on the results from the first stage, it actually joined with as part of the fifth stage itself, and then it has applied the map finally before saving it as text file. Okay, so this is the execution path. You can see there are 2 joins happening here. Okay, so one of the drawback here is, in case if you are trying to join a very big large table with a very small table, it is very common in data warehousing. Your fact tables are very large, whereas the dimension tables will be hardly negligible compared to your fact table. It will not even be 1%. So in those cases, rather than doing typical join like this is called as reduce join or shuffle join. Instead of doing shuffle join or reduce side join, there is a concept called map side join. And the way map side join is implemented as part of the Spark is using broadcast variables. So using broadcast variables, what will if we create a hash map, or if we just create a variable, and if we broadcast wherever your program is executing in the form of tasks, the results in that will be broadcasted to all those tasks, and you just have to look up into that, and you can process it further. For example, for this job, you can go to the stages, and you can go to each of the stage. Okay, there are executors and there are tasks within the executor. So in this case, there are 2 tasks to read the data from products and create a RDD out of it. Okay, and also apply the map, etc. So it took 2 tasks. So if I broadcast a variable, it will come to these 2 tasks. And also, if you go to the other stages in the life cycle, the variable which is called as broadcast variable will be broadcasted to all the tasks, and it will be cached in memory. Hence, you can actually look up into that, and you can get the results. So you will reduce the number of stages while processing smaller tables along with your bigger tables, and also as it will be cached in memory on all the tasks, the performance can be much faster. So it is traditionally called as map side join in Hadoop MapReduce world. The answer for that in Spark is broadcast variable. Okay, broadcast variables, and looking up into those broadcast variables. Those broadcast variable can be a single value. It can be a hash map also. So to leverage broadcast variables, what we can do is we can actually create a map, which is nothing but a Scala map of products, and we can register it as a broadcast variable, and products will be broadcasted to all the tasks. Hence, one of these stages will be reduced, and your performance can be a bit better. With this volume, you will not feel the difference, but if you actually have a very large table in our dataset and a small table such as products, you will see the difference in the performance. Okay, so we'll get into that in a moment about converting the same program into broadcast variables approach and see the performance difference. But before getting into that, let us look into accumulators also. So what is accumulator? Accumulator is nothing but a counter. In MapReduce terminology in Hadoop, we call it as counters. Here we call it as accumulators. They are primarily used for unit testing, data quality checks, etc. Okay, and typically, sometimes if you want to perform counting as part of the program, Many people will try to add a variable. Okay, like let's say I want to see how many times this map function is invoked. Okay, so most of the guys can end up doing this val or var, because we have to make it mutable. So var cnt equal to 0, and then as part of this map function, people tend to do this. Okay, but here you need to understand the clear distinction between what is running on the cluster in the distributed fashion and what is not running on the cluster. Okay, so as long as you don't use Spark APIs, that portion of the code will not be executed on the cluster. For example, in this case, you are trying to create the configuration object, context object, and all those things. All these things run on your driver program, not on the cluster. Similarly, validation of the paths will be done on your driver program, not on the cluster. Only when you do sc.text file, which is a Spark API, the code which needs to convert your file into an RDD, that is the portion which will be executed in the distributed fashion. Okay, and also 1 minute. I'm in the wrong program. Anyway, let's take the example of revenue per product per month. Whatever I explained still hold correct, but I want to use this so that we use the same program even for broadcast variables later. So let's have a look at this. So if I add a counter here like this, where cnt equal to 0, and let's say as part of the map function, cnt plus equal to 1. Okay, so here the scope of the variable is primarily controlled by your driver program, and you are trying to manipulate as that variable in the distributed fashion. So what will happen is this can actually result in inconsistent results. In the distributed mode, it cannot maintain the scope. So wherever this map function is applied, it cannot control the scope of this count. Okay, so even though you have count plus equal to 1, even if the program execute, still the count will remain 0. Same thing if you run in the local mode, probably it might work. So it can result in incorrect results. You have to be a bit careful. Whenever you want to perform this type of counting for sanity checks, you have to use concept of accumulators. You should never use local variables using var like this and try to add as part of your Spark APIs. Okay, you first need to distinguish and understand what is being executed as part of the driver program and what is being executed as part of the tasks in the distributed mode. Okay, in this case, only the code which is executed as part of the Spark APIs will be executed in distributed mode, and you cannot have a global variable which can be accessed as part of those APIs. It is not the correct approach, and at the same time, it will not throw compile time errors. So you have to be a bit extra careful here. Okay, so instead we should use accumulator, which will be managed by Spark. Accumulators will be passed to executors, and scope is managed across all the executors of executor tasks. Only when it is registered as accumulator, a variable is registered as accumulator, the scope will be managed by a Spark driver program across all the executors or executor tasks. Okay, accumulators can be used in any Spark APIs. It could be transformation or it could be action. Okay, so let's take the example of the same program, revenue per product for given month, and let's try to get number of orders for the month, get number of order items for the month, and so on and so forth. Okay, we will try to implement all those things quickly. And there are some issues that are already known with accumulators. Unless tasks are executed, you will not see details about counters. Okay, so if your program fail even before launching any task, you will not see any results of those accumulators. Spark guarantees accumulators to be updated only in first execution. So if some task fails and if it fails over, the results might be incorrect. This issue is prevalent in both transformations and actions. Now let us see the syntax about how we can actually use the accumulator. Okay, so accumulators have to be immutable like this. You cannot say var. You have to say val only. So and then you have to register using sc.accumulator. You can give the initial value and the description for that. Okay, so here I want to get orders for a month. Hence, I gave the name, and I will explain why I am giving the name and how you can access that information once we execute on the cluster. So for all the use cases which I have explained, or all the tasks which I have given here, number of orders for the month, number of order items for the month, uh, increment orders count as part of the map function after filtering on the month, and also increment order items count as part of the map function after join. Okay, so that we can get these two things. We are only trying to get orders count and order items count. Okay, so here I said orders count, and as part of the map function after filtering, I'm incrementing this accumulator. Once we declare as accumulator, if it is of type, because I have initialized to integer type, the accumulator is of type integer here, and I am incrementing here saying orders count plus equal to 1. Similarly, I want to get order items count, and after joining, I am just running order items count to see how many order items we are trying to fetch to perform this revenue revenue per product for a given month. Okay, rest of the stuff is same. There is no difference at all. So we can actually compile, copy, paste this code. Save it, and then exit from here. XBT package to build the jar file. And then trying to run on the cluster. There is no need to change anything as part of the Spark submit command here. We still use only 5 arguments. The execution is done. We can go to this, go back, go back, go back. Okay, so I can I'm sorry. I can check the history here. Okay, so we are trying to get order count and order items count. Order count we are trying to fetch as part of as part of the filtering the data. After filtering as part of the map function, we are trying to fetch. So if you observe this stage where that is being executed, okay, you can see the user defined accumulators also. So this will give the information about what the accumulator description is, and it has processed 5,892 records as part of the program. Similarly, if I go to order items, here also, okay, first we need to identify where I'm getting the information. I think yeah, I'm actually doing here after joining as part of the map function, I'm fetching order items count. If I do before join, what will happen? It will fetch all the records from the order items. Only after join, the filtering happens based upon the order ID, right? Because of the join. Hence, I have to do after join only to get the order items count for that given month. And you can see here, order items per month 2013 December is 14,729. Okay, so that is about accumulators. It is not as robust as Hadoop MapReduce accumulate counters. It has certain limitations, and it is not 100% reliable. Just for sanity checks, um, uh, we tend to use accumulators. Even MapReduce counters also are primarily for sanity checks. Now let us get into the broadcast variables. She is asking, can you please tell us the use of Livy server in Spark? I know it is a REST-based API. I have no clue about it. I never used that, so I cannot comment on that. Okay, so now let us talk about the broadcast variables. As we have seen, this is how the program is executed earlier. Uh, After broadcast, it will be executed like this. Okay, only difference is we will create a hash map for our products, and we will broadcast it into all the tasks, and we will do the lookup as part of our program. So first, let us see the concepts. At times, we need to pass broadcast uh, some information to all the executors. Uh, it can be done by using broadcast variables. It can be of any preliminary type, or it could be hash map also. When very large, the use case is when very large data set is tried to join with smaller data set, broadcasting dimension can have considerable performance improvement. Broadcast variables are immutable, so you cannot change it. You can only look up into those things. We can read data from HDFS or local file system, or even as configuration parameters, and then we can broadcast into the tasks. Okay, size of the broadcast variable should fit into the memory used by each of the executor task. Typically, if the executor memory is 1 GB and only one executor runs, broadcast variable should not exceed 256 megabytes. If it is typical. Depending upon your cluster, you might be able to use more than that. But typically, if your executor memory is only 1 GB, your broadcast variable should not exceed 256 megabytes in size. Okay, broadcast will be done using broadcast method of Spark context. The same way as sc.accumulator, we have sc.broadcast, and we can broadcast a variable. Let us take the example, the same example of revenue per product for a given month. Earlier, we have read products from local file system. We parallelized into RDD, and we have used the join to join that. Okay, and this is how the DAG look like for us. Now, if we actually broadcast it, it will look like this. Let's make the necessary changes to the existing code itself. So the major difference will be at the time of reading from the products uh, table. Instead of sc.parallelize on products, we can create a products hash map for the products, and then we can broadcast. Okay, so here the difference is only here. Rest of the stuff, joining orders and order items, is same. Only this portion of code will change a bit. Okay, so even you have to take care of reading the file and create a collection out of it. Once you read that, you can convert into a hash map and you can broadcast. Okay, how to convert a collection into a hash map? Let us uh, let us do that. Here I'm launching Spark Shell again. Okay, so it is launched now. So first, let me show you how to read the local files once again. Import source.io. This is very rudimentary way of doing it. You should know other APIs also under Scala.io, and you should use whatever is appropriate to you. The source itself might have so many methods like from string, from file, etc. And there could be some other APIs also, like buffered source. There is one buffered source under Scala.io. So there can be multiple APIs to deal with these things. You should be familiar with that as and when it is required. So first I have imported this one, and then I can read data of products saying source dot from file, giving the path data retail underscore db products part hyphen dot read lines. Okay, let me see the code real quick. From file get line, sorry. So I have started working on Python, so it is getting me a bit confused. So now you got the products, okay, and you can actually say products dot first or products dot head, I guess. No, products dot let me see, tab. I think I can say like this. Okay, so this is iterator, so I have to do the list. Okay, let me do to list. Now products is of type list. Yes. Now I can say products of 0. Okay, and you can see the product record here. So now I want to get the product ID and product name from this, because those two are the only things which are required for our problem statement. We don't need other stuff. So how can I do that? Here we haven't created RDD out of it, so we have to use Scala APIs, not the Spark APIs. So what I can do, I can say products.map, okay, and I want to create hash map of ID and name. So I can just say rec.split comma is the delimiter, int is product ID, and then the third parameter, the third value is the product name. So I can say rec.split 2. It will actually give us hash map of product IDs and product names. Once you get to this hash map, you can broadcast this one. Okay, so that is what happening here. So we created the products map exactly the way I have read the data, and then I just have to say sc.broadcast, and I have to apply toMap function. So this actually returns the list. So products.map is just list, but I want to create a hash map of it to broadcast. So I can just use toMap, and then it will actually convert it into hash map, and then I can broadcast saying sc.broadcast like this, and then we can actually use it as part of our Spark-based API, whatever code we want to write as part of Spark-based APIs such as map, flat map, etc. So now instead of using join as part of the map function, I'm trying to get the name based upon the ID. So let's revisit. So up to here, you are getting product ID and revenue. Once we get product ID and revenue, using product ID, I am trying to get the product name using this approach. I will explain that in a moment. And then we are just concatenating the revenue. So let me run this real quick. So first I will create variable in path. These are HDFS path. So it is public retail underscore DB. Okay, I don't want to save it anywhere, so I'm ignoring the output path. Val month equal to, let's say, 2013 December. For that month, I want to get the results. And then I am saying this accumulators. And I'm running this portion. So orders filtered, we are only getting 2013 December orders. We are ignoring rest of the stuff. And then we try to read order items. And also we join the results. Our revenue product revenue by product ID dot take of 10 dot for each println will give us product ID and revenue for that product for that month. Okay, from this I want to get the product name. Okay, so val local path equal to data retail underscore DB. That is where my local files are. And I'm reading the product data sets. Okay. And then we are broadcasting like this. This is pretty straightforward. So you can see that it is already broadcasted into the cache of the executor. So each executor have the cache, right? So whenever you said broadcast, it will be broadcasted to the executor's cache. And whenever task is run from the executor cache, it will be accessible by the task, and it will use it as part of that task. Okay. Now I can now let us understand why I am using vv.value.get product._1 blah blah blah. Okay, so if you look at products map dot take of 10 dot for each println, I'm getting 10 records. I should not use take. Okay, 1 minute. The list of, I think, list of products map dot first. There seems to be some question. Let me just give me a moment. No, 1 minute. Products map. Okay, it is written empty iterator. I don't know why. Probably this guy might have identified the issue. I will answer your question a bit later, Amok. Let me figure out the issue here. Okay, it did not read anything, so I'm reading again. Okay, now it's a non-empty iterator products map. Okay, and it is giving like this. How to read this? I want to just see. Okay, I know. So I just have to say products map dot for each println. Yeah, now you see we got the ID and the name, right? So if I want to access, if I want to get the name by passing the ID, what I have to do, I have to say products map dot get and 1345 is the ID. If I hit enter, products map dot dot value dot get, and then I have to give the 1345. Okay, I know the problem. I have to convert it into map. That's the gap here. So okay, so I have to say products map dot to map. And now it will become a hash map. Then I can say value dot get 1345. So iterator is not mapped directly. What's that? And also it is not identifying the value. Just give me a moment, okay? So val, yeah, I don't know why it is converting into empty iterator. Let me try this again. Okay, now products map is a non-empty iterator. Let me say m equal to products map dot to map. It will actually convert the products map into hash map. Now you can see the results. Now I can say m dot pick tab, and you can see the different different APIs. And out of this, value is not hash map function. Value is on top of broadcast variable. So value is not correct. Here I have to say get. If I want to pass a key and get a value, I just have to say this m dot get 1345, and you can see the value. And if you see, if I'm using get, the return type is of type sum. Okay, if there is a corresponding value for this, it will return of type sum. To convert it into string, if you want to use as part of the program, you have to convert it into string. If you just say get, it will convert into string. So it is very important to convert into string. If you directly want to get the value, you can also say m of 1345, and you will get the string directly. So it's up to you. I think as part of the program, you can also say bv dot value of product dot underscore one, and then it will give the result. Okay. So here, why we are giving product dot underscore one? We are trying to look up into this broadcast variable on top of this revenue by product ID. Now let us recollect what is revenue by product ID. Sorry, revenue by product ID. It is nothing but the collection. After joining orders and order items, we got product ID and revenue. Okay. For each println, you can see the results. And from here, I want to have a lookup into the broadcast variable and get the product name. That is our requirement. So using revenue by product ID, we have to apply the map because we want to transform this product ID into the name, right? So we can say map. Let's give the variable name as product. Okay, and then I want to get the product name tab revenue. So what I can do, our broadcast variable name is bv dot value dot get. Okay, product dot underscore one will give this one. That's why I'm using product dot underscore one. I'm passing the product ID to the hash map to get the product name, and it returns the of type sum. So I have to say get here. Okay, and then I can say plus tab plus product dot underscore two. Okay, There is some syntax issue. Okay, there is some task not serializable. Okay, again, the stuff is flushing, getting flushed out of memory using Spark Shell. That's why it is not giving the results. That's fine. I hope you got the logic. And then I'm trying to save it to the output path. Okay. Now I can copy this entire code. I will answer your questions in a moment. Save it, and then compile it into the jar file. And login back and run the Spark submit command again. There is no difference to this command. It is the same thing which I have used in all these topics. Okay, now it is running. Once it is done, we can actually go back. Okay, now it is already done. We can go to the tracking UI. Click on this. You can see. Okay, this is not the correct one. Or probably I might not have done the SCP. Yes, I think so. I did not do the SCP. Yeah, I did SBT package, but I didn't do the SCP. Now I am doing SCP. Now I am running again. Okay, let me take these questions. Amog is asking, so when program or job is finished, execution broadcast values in cache would be cleared. Yeah, executors themselves will be killed once the program execution is done. So whatever is in the memory will be gone. Okay, it is value. It's not values. We have to use value only. So now the execution is completed. I am refreshing this one. And clicking on the history. What happened? Let me see. Still, it is not using broadcast variable. Something is wrong. Revenue per product per month. Yes. Exit. Let's LTR. SPT package. So there is no changes in the code for sure. So let me do the SCP once again. Okay. The program name is revenue per product per month broadcast. Okay, that's why it is causing the issue. I have changed the program name, but I didn't change it here. Okay, now I understand. So here, what I have to do is I can go here and copy. Okay, I should have changed it here also. It should be broadcast, or I will just remove this one. There shouldn't be broadcast here. Anyway, let's. I will fix up the code over there. So for now, I just have to broadcast here. Okay, now I can go here. Now you see there are only 4 stages, and we did not do parallelize. We are directly reading data from orders and order items. It happened in parallel. Once those two things are done, then it actually joined the data as part of the stage 2. And finally, at this place, it actually does the lookup and get you the results. Okay, so you can actually look at the final step, and the broadcasting is the lookup into the broadcast is happening at this place. Okay, so that is how you can actually leverage broadcast variables to perform the map side join by doing the lookup into the smaller table while crossing the larger table. As it will be cached into the memory, and as every record will be available in all the tasks, the lookup will be much faster compared to the reduce side join. Okay, so that being said, that's about it with respect to accumulators and broadcast variables. As part of next 2 sessions, I will be covering Flume, Kafka, and Spark streaming. I'll be doing one end-to-end pipeline execution. I will not be covering too many basics. You have to put some effort on your side to understand what is going on with respect to Flume, Kafka, and Spark streaming. But it should be pretty straightforward if you practice. It shouldn't take a very long time. If you practice, you will be able to digest. And we will not be customizing any Kafka, or we will not be writing any code for Kafka or Flume. We'll be using the existing plugins themselves. And sometimes, if the plugins are not available, we might have to write a Java-based code or Scala-based code to extend the capabilities that are not available as part of those plugins. That being said, if you have any questions, I can take those things for a few minutes, and then we can wrap up for today. Those who are on YouTube, thank you very much for joining the session. We might not be able to answer all your questions because this is not meant for public discussion. And this is primarily for those who are joining my live sessions on WebEx, who are paid customers. For that reason, I'm not able to take all your questions, so bear with us. Okay, as there are no questions, we'll wrap up for today. And I hope today the session went very smooth. If that is the case, we'll try to use Zoom itself as part of our future sessions, the rest of the 2 sessions and also the other ones. Recording is being done. Once it is done, I will probably put it in S3. If it allow me to do it, I think Zoom actually records locally. If everything is smooth, I will share. Okay. That being said, thank you. Bye. And those who are on YouTube, thank you very much for joining the session. If you like this session, please click on the like button. It means a lot for us. If you have any questions, you can definitely ask on discuss.itversity.com. And if you want environment to practice, you can definitely use labs.itversity.com. you can go through our playlists, and you will see a lot of content covering vast area of topics within big data. And if you want to provide the feedback about the session, please wait until the video is streamed, and then put your comments there. Okay, thank you. Bye.